Direct and inverse variations. Introduction. In our daily life, sometimes we need to compare the things. Often, value of one quantity depends on the value of another quantity. If we change the value of one quantity, the value of the other quantity also changes. Suppose you go to market to buy 10 notebooks which cost rupees 65. Now, if you want 6 more notebooks, you have to pay more. Similarly, if you are cycling to school and you wish to reach little early, less time, you will have to increase your speed. We find that variation in one quantity brings a variation in another quantity. Variation. If two quantities depend on each other in such a way that a change in one results in a corresponding change in the other, then the two quantities are said to be in variation. The two quantities may depend on each other in such a way that increase in one brings increase in the other, and decrease in one leads to decrease in the other. If one quantity increases, then the other quantity decreases, and vice versa. Thus, there are two types of variations: direct variation, inverse variation. Direct variation, direct proportion. Consider the following examples. Speed of a moving object, train, car, etc., varies directly to the distance. If speed is more, the distance covered in particular time will be more. And if speed is less, then distance covered will be less. The cost of articles and number of articles purchased varies directly. To buy more articles, more money has to be paid, and for less articles, less amount need to be paid. More the working time, more work can be done. And if time is less, then less work will be done. If we put more men at work, then more work will be done in the same time. And less number of men can do less work in the same time. More the number of persons, more the food required. Less the number of persons, less the food required. From the above examples, we come to the conclusion that if x and y are two quantities such that if x increases or decreases, y also increases or decreases, then x is said to be directly proportional, varies to y, and is written as x directly proportional to y, or x is equal to ky, where k is the constant of proportionality, or x upon y is equal to k. If two quantities x and y are in direct variation, the ratio of any two values of x is equal to the ratio of the corresponding values of y. That is, x1 upon x2 is equal to y1 upon y2, or x1 upon y1 is equal to x2 upon y2, or x1 y2 is equal to x2 y1. Example: if 12 apples cost rupees 30, what is the cost of 28 apples? Solution: let the cost of 28 apples be rupees x. Then we have apples 12 cost in rupees 30, apples 28 cost in rupees x. More apples, more the cost. Then it is the case of direct variation. Therefore, 12 upon 30 is equal to 28 upon x. This implies 28 into 30 upon 12 is equal to 70. Alternative method: 12 apples cost rupees 30. Therefore, 1 apple costs rupees 30 upon 12. Therefore, 28 apples cost rupees 30 upon 12 into 28, which is equal to rupees 70. Hence, 28 apples will cost rupees 70. Example: the bus fare for the journey of 240 kilometers is rupees 84. What will be the fare for Nainital to Delhi having a distance of 432 kilometers? Solution: let the fare for 432 kilometers be rupees x. Distance in kilometers 240. Fare in rupees 84. Distance in kilometers 432. Fare in rupees x. More the distance, more will be the fare. Therefore, distance covered and fare varies directly. Therefore, 240 upon 84 is equal to 432 upon x. This implies x is equal to 432 into 84 upon 240. This implies x is equal to 151.20. The bus fare for Nainital to Delhi is Rs 151.20. Inverse variation, inverse proportion. If two quantities are such that an increase in the value of one quantity causes the value of the other quantity to decrease and vice versa, then it is said that the two quantities are inversely proportional. If x and y are two quantities which are inversely proportional, then we write x inversely proportional to 1 upon y. This implies x is equal to k into 1 upon y, where k is the constant of proportionality. This implies xy is equal to k. If two quantities x and y vary inversely to each other, then the ratio of any two values of x is equal to the inverse ratio of the corresponding values of y. That is, y1 is equal to x2, y2. Consider the following examples where two quantities are inversely proportional. A. More the speed, less the time taken to cover the distance and vice versa. B. More men at work, less time days will be taken to finish the work and vice versa. C. 1. Suppose A can finish a work in n days, then work done by A in 1 day is equal to 1 upon n. 2. Suppose the work done by A in 1 day is equal to 1 upon n, then time taken by A to finish the whole work is equal to n days. Now let us take few examples to clear the concept. Example: if x and y are inversely proportional, then find the value of A and B. X 20, y 3. X A, y 4. X 5, y B. X2, y 30. Solution: since x and y are inversely proportional, therefore 20 into 3 is equal to A into 4. This implies A is equal to 15 and 20 into 3 is equal to 5 into B. This implies B is equal to 12.
Example: in a hostel, 100 students had provisions for 130 days. After 10 days, 20 students left the hostel. How long would the remaining food last? Solution: since 20 students left, therefore, the remaining food is sufficient for 100 students for 130 minus 10 days is equal to 120 days. But number of students left is equal to 100 minus 20 is equal to 80. Suppose the remaining food lasts for x days for the remaining 80 students, then we have number of students 100, number of days 120, number of students 80, number of days x. If students are less, food will be last for more days. Hence, it is a case of inverse variation. Therefore, 100 multiplied by 120 is equal to 80 multiplied by x. It implies that x is equal to 100 multiplied by 120 divided by 80 is equal to 150. Hence, the food will last for 150 days. Example: A can do a piece of work in 30 days, while B can do the same work in 24 days. In how many days can they complete it if they work together? Solution: A's 1-day work is equal to 1 divided by 30, B's 1-day work is equal to 1 divided by 24. A plus B's 1-day work is equal to 1 divided by 30 plus 1 divided by 24 is equal to 9 divided by 120 is equal to 3 divided by 40. 3 divided by 40, work A and B by 1 divided by 3 days. Hence, A and B together can do work in 13 multiplied by 1 divided by 3 days.
Example: 10 laborers can repair a road in 15 days. In how many days can 25 laborers repair the same road? Solution: let the required number of days be x. Number of laborers 10. Number of days 15. Number of laborers 25. Number of days x. More laborers will take less days to repair the road. Hence, these are inversely proportional. Therefore, 10 into 15 is equal to 25 into x. This implies x is equal to 10 into 15 upon 25, which is equal to 6. Hence, 25 laborers will take 6 days to finish the work.